Hello, and welcome to this edition of Pre-Calculus. This week, we've talked about average rates of change. What I wanted to do today was have an example of a real-life scenario of average rates of change. Why would we care about learning this type of thing? So let's say that Mr. Blue Guy and Mr. Red Guy are having a race. They are trying to run 1 mile. So I'm going to label my axes here. This is distance versus time. And my blue guy and my red guy are running a race. And Mr. Blue Guy and Mr. Red Guy both start having gone 0 miles and having taken 0 minutes to do so. They start at 0, 0. Now, Mr. Blue Guy is all about consistency. You can see here, he's even thinking, I love consistency. He's all about consistency. He just wants to get to the end with as good of a pace as possible. He runs straight through. Mr. Red Guy doesn't do that. Mr. Red Guy has a different route. He is really fast at the beginning, but then tires out. He tires out, starts to run slower. And then at the end, he sees the blue guy overtaking him. He catches up, and they both reach the end at the exact same time. You can see here that Mr. Blue Guy and Mr. Red Guy have different paths. However, what I wanted to see is what happens to their average rates of change. Well, we've talked about how an average rate of change is really basically the same thing as a slope, which we've calculated many a time as m is equal to the delta y, the change in y, over change in x. So we can see here that both Mr. Red Guy and Mr. Blue Guy ended after 10 minutes. They've gone 1 mile. They've both ended at this 10:1 mark. So if I take my change in y, that gives me 1 minus 0. I've gone 1 mile. 1 minus 0 over how long it took me, which is 10 over 0. So I get that I've gone 1 mile in 10 minutes, which is pretty obvious. We should know that already, right? This is just the slope of a linear line. However, the interesting part is what happens with the red guy. Well, red guy, if we calculate the average rate of change or slope, whatever we want to use here, average rate of change for the red guy, we can use that fancy new vocabulary. We're going to have change of y over change in x. So notice here that my end points are the same. I'm going to have the exact same change in y, 1 minus 0, and the exact same change in x, 10 minus 0. So I'm going to once again have 1 mile over 10 minutes. Both ways, the average rate of change is actually identical. This hammers home an important point. When calculating average rate of change, the things that matter the most are the end points of the interval. Even though these paths are completely different, they have the same exact average rate of change. Notice, even if my path was totally crazy, even if it had all sorts of stops and starts, if I arrived at the same endpoint at the same time, if Mr. Yellow Guy joined in and also came and also finished in 10 minutes, even though his path looks completely different to mine, he would still have the 1 mile over 10 minute average speed or average rate of change. So to find how fast you're going on an average, this is where you'd use average rate of change, which is very useful if you're running a race, if you're driving, and many other use scenarios. Now, naturally, what you may think next is, well, what if I actually wanted to see what's happening during the race of Mr. Red Guy. So Mr. Red Guy has a pace that's a little bit not constant, right? So if I'm having, let's have these same bounds as before. So we were 5 minutes, 10 minutes. Let's put those back. 5 minutes, 10 minutes, 0.5 miles, 1 mile. So same as before. So Mr. Red Guy, let's say that he's going really fast, and he reaches half a mile in 2 minutes. Super, super, super fast, like Olympian speed. Reaching it in 2 minutes. He can't sustain that pace, so he starts to go slower. Then, all the way up until 9 minutes. So he's gone half a mile. Now, at this point, 9 minutes in, he's at 0.9 miles. Then finally, at the very end, from 9 minutes to 10 minutes, he kicks it, and he has another sprint to the finish. So I have these 3 points. What I'm wondering here is, where is my average rate of change the highest? Where is my average rate of change the highest? In other words, when am I going the fastest? Well, it's useful. It's useful if we label all of our points. So this point over here is 0, 0, where we're starting. Over here, we ran so fast. We're at 2, 0.5. Over here is another interesting point, 9, 0.9. And over here, we have 10, 1. So where is my average rate of change the highest? Where am I going the fastest? Well, all I need to do is consider the different intervals. So practicing our interval notation on the 0 to 2 interval, my average rate of change is always that same formula. On the interval from 0 to 2, my change in y is 0.5. 0.5 is how much I've gone minus 0. Over my change in x, 2 minus 0. So I've gone 0.5 over 2, or 1 mile per 4 minutes. You can see that's relatively fast. It might be easy to compare for in decimal. So we can go 0.25 is a decimal form. So that I've covered this interval. Now let's look at the next interval, from 2 to 9. You can kind of visually see that that's going to be lower. Let's compare that algebraically. So I'm going to once again have that same formula. And now I'm going to compare what's happening here. This is going from 0.9 minus 0.5 miles, because it's this and this, over my interval from 2 to 9, so 9 minus 2. This would be 0.4 over 7. Okay? 0.4 over 7. And finally, from 9 to 10, I can have m is equal to change in y over change in x is equal to my 1 minus 0.9 divided by 10 minus 9. I'm going to put that in here. 1 minus 0.9 over 10 minus 9. And that gets me 0.1 divided by 1, or 0.1 at the end. So I ran my last 0.1 miles in 1 minute. So here I have, again, the units are always miles per minute, miles per minute. And this one, 0.4 divided by 7 is also miles per minute. That's really slow. So I can see here that this, at the beginning, my Olympian speed, is the fastest. And this is how we can compare different speeds. So this, my friends, is how you would approach this type of problem through an algebraic rate of change comparison. And with that, I wish you good luck, and thank you for listening.